Hey guys, so here's some worked examples of the graph sinusoidal functions phase shift Khan Academy assignments. All right, so I'm gonna start off with this problem, and for all these problems, you need to find really 5 things. And we've looked at this in a prior video: amplitude, midline, period shift, and phase shift. Phase shift is gonna matter in these problems because we do have a plus c, and that's what the phase shift tells us, is that c value. All right, so we want to come up with this function. Let's first find the midline. All right, so the midline looks like it's going to be 6, right? It's going to be the mid mark between the maximum and the minimum of this function. There's a way that you can find it. It's really an average of the maximum and the minimum. So 9 plus 3, average it divided by 2, you get 6. That's the midline. So y equals 6. The amplitude is going to be how high you have to go from the midline to get to the maximum or the minimum. And there's another calculation to do that. You can subtract the 2, the max and the min. 9 minus 3 divided by 2, you get 3, is that amplitude. So that's the distance from the midline to the maximum. And also the distance from the midline to the minimum is 3. That's the amplitude. All right, so that's the boundary for my graph. It's the highest and the lowest it'll go. The period, all right, well, the period we want to look at, we've got these 2 points. How far does this go before it repeats? Right? So you want to think, using these 2 points, if we kept going just a little bit further, right, this would be where it would stop before it repeated again. That's one section of this graph. It's one way to look at this. We want to use the points that it gave us. So that's one section of the graph. Right? We can divide it into 4 chunks. And this distance between these 2 points is going to be 1/4 of that total period. All right, so what is that distance? That goes from -1 to -3.5. Well, let's find it and subtract the 2. -1 minus -3.5. Then I'm going to multiply that by 4, and that's going to give me my total period. So let's figure that out. So we've got a total distance of 2.5 multiplied by 4. Well, 2.5 times 4, that's a total period of 10, is that length. All right, well, what about the shape of this function, or this graph? We have 2 options. We've got sine or cosine, and it really doesn't matter which one you choose, right? But we've got a max and a min and a midline. Sine starts at the midline on the y-axis. It goes up, down, and comes back up, and ends at the midline. That's 1 period of sine. Cosine starts at the max value on the y-axis. It goes down, then comes back up for 1 period of cosine. All right, so which one do you want to use? It doesn't really matter. You should still get the right answer, right? I personally, you want to use the points that it gave you, right? So it gave me like a minimum point and a midpoint. So I'm just going to use this midpoint and kind of assume that I've got a sine function here shifted around. What about the phase shift? Well, comparing to my shape graph that I'd drawn, it looks like it moved left 1 unit if I compare that to the graph that I have, my actual graph that I have on the left here, right? It was on the y-axis, but then I shift it to the left 1 unit to get the graph that I have for this problem. So my phase shift is left 1 unit. All right, so what does this function actually look like then? If we put together all the pieces, we've got an amplitude of 3. So my function that I'm going to use is sine. Then I have my period of 10, but that's not the number that I put in here. All right, there's actually a formula for this to find the number that I put into my function. It's 2 pi divided by the period. What's 2 pi divided by 10? That's just pi over 5. So that's the number that goes in my function, pi over 5. I'm going to open parentheses, I'm going to put an x, and then what was my phase shift? Left 1. It's the opposite of what you would expect. So left 1, you would think it means minus, but it actually means plus 1 in my function. And then my midline is plus 6 at the end. So this should be the function for my graph. Let's type it in. All right, new problem. Let's try the same thing. Find our amplitude, midline. We get a period, the shape of the graph, sine or cosine, and the phase shift. And then we can write our equation or our function. All right, so looking at our graph here, let's try to find the midline. And if you remember, there's a formula, right? We have a maximum and a minimum. What we're going to do is we're going to average those two. So I've got a max of -3 and a minimum of -9. Average them. Again, -12 over 2 is -6, which is that midline. It's like an average between the max and the min. So we'll draw a nice horizontal line, midline at -6. All right. What about the amplitude? You can kind of count on your graph. There's also a formula for it. If instead of adding the 2, the max and the min, we subtract the 2 and then divide it by 2. And then take the positive value of that. It's going to be 3. So the amplitude is 3. In order to get to the max and the min from the midline, you only have to go up and down 3. That's the amplitude. All right, so it's the boundary of my graph. So the amplitude's 3, the midline's -6. Now what about the period? Well, we really only have to find a couple of points. Find where this graph repeats, how far do you have to go until it repeats. So here's a section, just picked a random section that happens to include one of the points that it gave me, right? And so you can see, right, that part that I highlighted here, that's one period with a length of, well, how far do I have to go from the first dot to the second dot? A length of 1, right? So my period is 1. That's how far you have to go before it repeats again. Now what about the shape? Well, if you kind of look at the area that I just highlighted, you might be able to guess, but in general, sine starts at the midline, goes up and comes back down, and then goes back up again for one period, right? Cosine, though, is going to start up at the max, right, and it goes down and then comes back up again for one period. Now, if you look at the graph, like I said, like I was talking about, that I had highlighted in yellow here, we started at a max, right? That's the maximum value, you go down and come back up. So I'm going to use cosine for this. All right, you could use sine if you wanted to, but it's just easier in this case to use cosine because we're starting at the maximum point here. All right, that's one of the points that it gave us. All right, so we're going to use cosine for our shape, for the function. Also, if you look at the original function, the original directions, it told us to use cosine. All right, so we could have just taken it from there. All right. And the very last thing is going to be the phase shift. So cosine starts on the positive x-axis. I'm sorry, positive y-axis, right? For my cosine graph, I'm going to erase this bit here. I'm going to use this particular period of my cosine graph. Doesn't matter, I could have used the other one. I would have gotten a slightly different answer for my function, but it would have been correct. But I'm going to use this one because it includes this point here, right? And it got shifted over 4 units, it looks like. I'm sorry, it looks like 2 units to the left, right? From the y-axis. And so that's my phase shift. I shifted that cosine function left 2 units. So put all that together. All right, let's make sure we understand where this 2 pi comes from, right? It comes from our period. We don't put the period in our function. We put the period into this formula. 2 pi divided by the period gives me the number that I put into my function. So 2 pi divided by 1 is 2 pi, and that's the number that goes into my function. All right, so let's input this equation and see if we're right. Nice. All right, here's a different type of problem where it gives you the function and we need to modify the graph in order to match the function. We're going to do the same thing. We're going to find the amplitude, the midline, the period, the shape of the graph, and the phase shift from this function, and then we'll use that in order to graph it. All right, but there's one important thing we have to do first. All right, and there might be another way of doing it, but this is my way. We actually need to factor out this number that's in front of the x, the 0.5. We're going to factor it out, divide both things inside of the parentheses, both terms divided by 0.5, and then write what's left over. We've got 1x is left. If if I divide 0.5 by 0.5, factor it out, you get an x that's left, right? What about 0.25 divided by 0.5? That's 1/2 of 0.5, right? 0.25 is 1/2 of it, and you have a pi left over, so pi over 2, and then minus 5. So that's the equation I actually want to use. All right, we've got our amplitude in the front, we've got our midline at the end, -5. We've got our period, which is a formula, 2 pi divided by b, where b is that number in front of x, the 0.5. So 2 pi divided by 0.5 is 4 pi. And then what about the shape? Got a cosine function, so my shape is cosine, which has a certain shape to it, right? It behaves in a certain way. Got my midline, my max, and my min. And cosine, like we said before, starts at the max, comes down, and then goes back up for a length of 1 period. All right, so that's going to be the general shape of my graph. And then the phase shift, this is why we rewrote this function. My phase shift is that negative pi over 2. The negative actually means the opposite of what you would expect. It means shifted to the right, pi over 2. All right, so we got everything we need. Let's graph this guy, the midline at -5. So I'm going to drag this middle point down to -5 because it's the point that's at the middle of the graph. So that'll go through my midline. All right, what about my amplitude? It's up 2, right? It's got a height of 2, so it goes up and down 2, and those are the boundaries of my graph. All right, now I'm going to use the shape of cosine, right? It starts on the x-axis at the maximum value. I'm sorry, it starts at the y-axis at the maximum value, and we've got a period of 4 pi. Right? I'm going to divide this into 4 pieces in order to get the nice shape of my cosine function. There we go. That's more or less what it should look like. All right, so I'm going to drag these points so that they kind of match this graph. All right, I got one point at 4 pi, -3, and another at 3 pi, -5. So let's move these 2 points. 4 pi, -3, 3 pi, -5, and I got it wrong. Why did I get that wrong, do you think? Well, if we go back, there's one thing that I actually forgot to do. And that was the phase shift, the very last thing. I didn't shift this graph to the right by pi over 2. So I'm very, very close. I need to take all the points that I've got, and I need to move everything to the right by pi over 2. So it's very, very close. Let's see. There are all my new points shifted all to the right by pi over 2. Let's move this over just a little bit by pi over 2, pi over 2. Still wrong. Okay. I didn't move it enough. There's pi over 2, pi over 2. These graphs are tricky. There we go. All right, and the very last problem. So we're going to do it the same way. Got our amplitude, our midline, the period, the shape, and the phase shift in order to graph this thing. All right, remember the very first thing that we want to do when we have these functions is rewrite them. All right, so we got 0.5 sine. I'm going to take that 0.25 in front of the x and factor it out in parentheses, so divide it out. So I got a 0.25 in the front, and then what's left over is going to be an x. And then what's 0.75 divided by 0.25? That's 3 pi. There's a pi in there as well. So 3 pi and then minus 5 at the end. So this is the function I want to use. This will give me all the correct information that I need. All right, so we've got our 0.5 in the front. That's my amplitude. We've got our midline. It's -5 here at the end. We've got our period, which is going to be the trickiest one. You have to use a formula, right? So 2 pi divided by b, 2 pi divided by, that b is the number in front of the x, so 0.25. So 2 pi divided by 0.25 is going to be 8 pi. That's my period. Right, the shape is going to be easy. This is going to be sine, right? It tells me in the function sine. It's going to have a sine shape, and then the phase shift is this plus 3 pi. It's the opposite of what you would expect, right? It means left 3 pi. I'm going to shift this whole thing to the left by 3 pi units. All right, so using all this information, I'm going to graph this guy. So my midline, this is always what you want to start with, is -5. It's a good reference point. -5 is my midline. So I'm going to go to my graph, drag that middle point down to -5 so it rests on my midline. There we go. All right, then what about my amplitude? My amplitude is 0.5. So go up 0.5, down 0.5, and that'll be the boundary of my graph. So it's a really, really thin graph. It doesn't go up and down very high. All right, what about the shape of this guy? So sine, what does that look like? I've got a max and a min, and I have a midline, right? So sine starts on the y-axis at the midline. Goes up, down, comes back up, and that's one period of sine. All right, so that's going to be the general shape of my graph. All right, so let's use this period of 8 pi. That's the length of that period. But I only have 4 pi here on my graph, right? It doesn't go all the way out to 8 pi. It's halfway. So where's the halfway mark on the sine graph? It's right here in the middle, which is where it crosses back through the midline. Right, so at 4 pi, that's halfway through the period. That's where my graph is going to cross through the midline, through the green line again. All right, which is going to be right there. So it's going to be very, very flat. It's going to go up and then come back down right there, just like that, more or less, through the midline right there. All right, and last thing, don't forget the phase shift at the very end, right? So we have to shift this thing to the left 3 pi units. All right, so I'm going to take all these points, I'm going to shift it left 3 pi units. Over here to -3 pi, I've got this guy at 2 pi. I'm going to shift it to -pi, left 3 pi units. All right, so it'll look all right, so it'll more or less look like that. So I need to move this green point maybe here, and then move this middle point over here to the left. So it rests on the midline here, and then that'll give me my graph. So this top point looks like it's at -pi, -4.5. And this is at -3 pi. It's on the midline, so it's -5. So those 2 points I'm going to create here. I'm going to plot them here. -3 pi, -5. And then we had -pi, -4.5. This is my nice flat graph. Let's see if that's correct.